Good day, everybody, and welcome to this presentation. I'm Denis Gagné from Trisotech, and I'm just here really to introduce Michael Scalzo. Michael is the Director of Clinical Pathways at Dana-Farber. They have some very, very exciting technology that they're leveraging into taking care of patients the way it should be. Michael, it's all yours.
Great. Thanks, Denis. Good afternoon, everybody. Thank you for joining us today. I'm going to talk a little bit about some of the work that we're doing at Dana-Farber using model-driven clinical decision support to manage side effects of cancer treatment at scale. Okay. So just a little bit on the metrics side. So when we're thinking about side effects of cancer treatment, unfortunately, of which there are many, about 97% of patients that are receiving chemotherapy have at least one side effect related to their treatment. That also results in about 1 in 3 ED visits after chemo. Great, awesome. Which are typically preventable, which is one of the things that we are very focused on at Dana-Farber. And on average, that's about a $22,000 cost when we look at those preventable ED visits, and ultimately those that lead to hospitalization as well. So this was kind of the gap that we were really looking to focus on from a Pathways program perspective. And I'm going to talk a little bit about today how we did that using Trisotech, Epic, and some other resources. So the Pathways program at Dana-Farber is a group of clinicians, informaticists, data analysts, as well as IT specialists. And we're really focused on building vendor-agnostic clinical decision support solutions, meaning solutions that are portable and can easily integrate with multiple applications. As many of you know, at large healthcare organizations, there are hundreds, if not thousands, of different software applications that are in use, all of which tend to kind of hover around the main EMR as the main component, but our focus is really, again, on building these shareable clinical pathways that are easily deployable. So this is just a quick overview of our group. We have specialists from each of the disease centers that we implement these products in, so we get clinical input from not just medical oncologists, but medical oncologists who subspecialize in specific areas of treatment, breast, GI, GYN, etc. So the first thing I want to talk a little bit about is our deployment infrastructure at Dana-Farber. So the clinical pathways that we've developed, we've built out in the Trisotech Digital Enterprise Suite application. And one of the things that we worked through pretty early on is from a data security perspective, obviously it was very important for our organization that if we were integrating directly with our Epic instance, that we had on-prem deployment of the Trisotech platform so that the models that were being used were not being accessed by Epic outside of our network. So the first thing that we did is we actually leveraged Trisotech as a solution, their digital distributed container model, and that actually allowed us to deploy containers on our Microsoft Azure instance, our internal Microsoft Azure instance at Dana-Farber. And so all of the Epic examples that I'm going to give today, they are all accessing API endpoints that are stored in these containers within our network. So the great thing about this is we can still leverage Trisotech's cloud-based application to build and rapidly deploy our models, and then every evening those containers automatically refresh on our Azure instance, and we get the most recent version of the model that we've published in Trisotech. Alongside this, we also have an analytics infrastructure that we've set up, and I'll talk a little bit about Trisotech's emitter functionality that we use. But from this perspective, basically, we have a database that we have built that is integrated with our Snowflake instances, and then the models in those containers that I was referencing are actually accessing data from these Snowflake databases so that we can remotely store and manage all of our treatment data that we use in order to feed these pathways. So that's just a little bit on the infrastructure side. So the kind of core function that Trisotech really provides is around using BPMN and DMN to build and deploy clinical pathways. So BPMN is business process modeling notation. It's a way to model standard processes using a standard set of parameters. Decision modeling notation, which we'll look at in a second, is the same, but it focuses on primarily modeling decisions. So when you think about clinical pathways, what they really are is they're a network of decisions and processes that are followed. And I will say that at Dana-Farber, our Pathways program has been through multiple iterations, so this is actually kind of our version 3 of what we deployed. Prior to this, our approach typically was that we would partner with a third-party software vendor, and they would develop a custom standalone application that we would use to build and deploy our models. The problem with that is that it's very difficult to build an application and also then build a standardized way of modeling data, processes, and decisions. And so what ended up happening is we built all this excellent content in these third-party applications, and there was no way to get them out of those applications. And even if we were able to, another IT platform wouldn't be able to actually consume that information because it wasn't created using a standard set of parameters. I'll talk a little bit about how we leverage HL7 Fire as well as part of this, but that was also a big key component, is we did not have any of those HL7 Fire resource structures built into our previous generation of pathways, whereas we do now, and again, that's 100% enabled by TriStech. They actually have the full library of all the HL7 Fire resources built into their application. So for us, when we're modeling, it's just a matter of dragging and dropping those resources into our model, which makes it very easy for us to build those. So this process model on the screen is actually the process model that we use currently for what we call our preemptive symptom management pathways. So our preemptive symptom management pathways are pathways that focus on providing preemptive recommendations for symptom management to providers at the start of treatment. So we're actually making recommendations to clinicians in EPIC when they're initiating patients on treatment, so when they're starting them on specific protocols. And those recommendations include side effect profiles for certain combinations of side effects that you might receive given the drugs in the regimen. That also includes sets of medications that can be prescribed, as well as education that's given to the patient up front before, again, they actually start treatment. So we'll actually take a look at what that looks like in our EPIC instance in the next couple slides, but that's really the focus of our preemptive management pathways. We're in the process of, right now, we primarily focus on the GI side effects just because those are so common, especially nausea and vomiting. And then actually this year we're also going to start rolling out recommendations on some of our mucocutaneous side effects, so side effects that affect the skin and the mucous membranes. So let's talk a little bit about DMN models. So they're telling me to come a little closer. So these decision models are what we use, again, to model specific types of decisions. So the process models that you saw on the previous screen, what these are actually defining are the process by which we collect data from EPIC, we process that information, we feed it into these decision models, we take the outputs of those decision models, and then we display it back to the end user in EPIC. So again, this first section is very process focused. So in that example, what we're doing primarily on the preemption side is when a provider starts a patient on a protocol in EPIC, so when they apply a beacon protocol and they create a treatment plan, that triggers in EPIC what's called an Our Practice advisory, formerly known as best practice advisories. And this is the way that EPIC manages CDS hooks. So these are workflow triggers that we can configure that fire based on certain parameters in EPIC. And then once those triggers are met and that OPA fires, we've actually defined sets of HL7 Fire prefetch queries that pull specific data and send it to TriStech ahead of time before we're actually running them through those models. That includes things like the treatment plan that was created, information on the practitioner who created the treatment plan, information on the patient, as well as information on the encounter and the location as well. And so that data, we take a subset of that information, specifically what regimen is being used, and we feed those into these decision models. And these decision models are really what allow us to, again, take an output from EPIC and define a set of recommendations. So these models are really what allow us to say, based on a given protocol, these are the side effects that we know of, and these are the recommendations that we want to make and push back to the user in EPIC. One of the other things that we did, again, I mentioned the CDS hook function. So CDS hook is just one way of deploying clinical decision support in EPIC. We're going to switch microphones, okay. All right. So CDS hooks are just one way of deploying CDS in Epic. The again, the primary focus of these CDS hooks are they pull data and then they will visualize that information back to the user in what's called a CDS card. So within an OPA in Epic, what you're actually looking at as a user, which I'll show you in a moment, is one of those cards. And so the one thing with the CDS hook function that's a little bit tricky is that it's not particularly dynamic. It's really more built to display static information to a user. And so for us, that was a little bit of a problem because given the different protocols that we're using, there might be situations where, for example, the protocol might not have diarrhea as a side effect, and so we don't want to waste providers' time or valuable space within the EMR displaying information that's not necessary. So what we actually did is we worked with TriStech to build out this very specific DMED model that we called the card builder. And what the card builder does is it basically allows us to hide and show certain components of that CDS card based on certain parameters. So another great example of that is that in certain situations, primarily when a regimen contains an immunotherapeutic agent, there's actually certain education that we repress. So for example, if a protocol typically has diarrhea as a side effect, we have a set of standard diarrhea patient education that we provide. If it's a protocol that does have diarrhea as a side effect, but it also includes an immunotherapeutic agent, we don't provide the standard diarrhea education because typically the side effect that they're experiencing is the diarrhea from the immunotherapy, and that's an entirely different ballgame as far as management. So we've built out logic that actually, again, can identify those protocols and dynamically adjust these recommendations based on different input parameters. All right, so now we're gonna actually take a little bit of a look at what this looks like in our Epic instance. So this is how we implement the preemptive symptom management pathways in Epic using these CDS hooks. So when a provider applies the treatment protocol, and this is basically real time for the clinician, so it's less than 5 seconds between when they actually initiate the protocol and they're seeing this response. And so they're going to get information on the Beacon protocol. They're going to get a regimen-specific teaching sheet, which is education specifically for that regimen. They're going to get a dynamically displayed risk table that's going to adjust based on the side effect profile of that regimen. They're also going to get a set of take-home medication recommendations. They'll get symptom-specific patient education, and they also get a link to a smart set. So we've actually, in our EMR, we've dynamically templated all of the orders based on our recommendations. So I'll show you this in a minute, but basically, if the provider acknowledges this recommendation, it will bring them to a smart set, which has our recommendations pre-selected. So it's basically a one-click ordering capability where they then can automatically send those prescriptions electronically, and they can send those education materials directly to the patient via Gateway. But this is what the OPA user interface actually looks like. And again, everything you see in basically that portion of the screen, that we control all of that from within TriStech. So we have 100% control on what displays and what doesn't display. The one thing I will say is for anybody who is familiar with or has done builds in Epic, especially with our practice advisories, to build and manipulate that content directly within Epic is a lot more complicated than to do it this way. So basically in Epic, each component would have to be built out as like a discrete data element. It would have to be mapped. It's a very complex process. And so you'll just see here as an example some of the patient education that is provided to our patients. So this is actually what the smart set in Epic looks like that's linked. So again, this smart set will dynamically change based on the side effect profile. So in this case, this is a regimen where the nausea vomiting risk is low or minimal. And so we only recommend 3 out of the 6 standard medications that we recommend they prescribe. And you'll see here that we've pre-selected them again so that they can automatically just click that button and order them. And then again, the patient education that displays at the bottom. The regimen teaching sheet that you see here, that also dynamically changes based on the protocol that's been applied. So for example, this is specifically the alpelisib fulvestrant teaching sheet that we've created. If this was a different protocol, it would be a different teaching sheet that would display and the provider could order. So the other thing I wanted to talk about a little bit is everything that we just looked at really is driven by the protocol. So we do everything for these preemptive pathways at the protocol level, meaning essentially what we're doing is we have sets of recommendation that we've tied to the protocol, and we basically look at the protocol that's included in the prefetch when this OPA gets triggered. We match it with the protocol and our recommendations, and then we provide our recommendations back to the user. We recently had a little bit more of a complex use case when we rolled out to our breast oncology clinic. So this is basically an example where these kind of one-to-one mappings don't really work anymore because of the complexity of the regimens that are being given. Many of you, I'm sure you've probably seen the commercials, they're everywhere, for a medication called Keytruda, which is a immunotherapeutic agent that has had a great impact not just in breast, but in a wide range of cancer treatments. And actually, after it was studied in some initial use cases, there were batch trials that were run basically where they looked at its applicability over a variety of different types of cancer. And these studies were called Keynote studies. And so specifically for breast, there is a study that was done that's called Keynote 522. And basically what it is it looks at pembrolizumab in combination with Taxol and carboplatin, as well as doxorubicin and cyclophosphamide. And there are 4 or 5 variations where the Taxol and the carboplatin and the doxorubicin and the cyclophosphamide are given in different orders and different durations. And so the thing here is that for some of these specifically, especially in situations where the AC combination, so the doxorubicin and the cyclophosphamide, are given later, the risk of nausea vomiting at the beginning of treatment is actually much lower. So it's not until they start that second set of the protocol where that nausea vomiting risk actually jumps much higher to high. And so in order to facilitate this, we needed a way to be able to basically find out at what point the patient was in the treatment protocol, because now not only did we need to make a recommendation at the start of treatment, but we now needed to then escalate that risk level and make a new set of recommendations once the patient had started. In this case, it's cycle 5, day 1 is when they start that AC portion. So what we did here is we actually, again, used these prefetch queries, and we updated these prefetch queries to essentially look at the cycle level care plan information. And so we were able to pull out the cycle that the patient was currently on and the status. So in this case, we would switch the recommendations when that patient again was starting cycle 5, day 1. So we would look at any patient who had a cycle 4 that had a status of complete, and then we would be able to switch the card and display some of this additional information. Great. And I'm going to actually fast forward through a couple of these slides just to talk a little bit about the AI component. So one of the things that we are actually looking to do from an AI perspective is that right now, when we do this work, we manually review all of our protocols in Beacon, and we assign side effect profiles to those protocols basically by hand. We do them with the pharmacist, but it's not an automated process. Now, there are a lot of different resources that are available that can help with this. So for example, the FDA has an open API that allows you access to the side effect profile information from the package insert itself. And so there are also other resources such as RxNav, which provides standardized drug data using the RxNorm database. And so one of our goals with AI in the future is actually to be able to automate this side effect profile mapping process, so to be able to take our protocols from Epic, break them down into discrete components, and that's actually using a little bit of a newer ontology that not a lot of people might be familiar with, but there's a new standard that's called hemonc.org, and basically what it's focused on is it's developing a way to standardize the representation of how regimens are written, specifically oncology regimens, because right now there is no standardization, which makes it very difficult when you're looking at comparing protocols across organizations. So this is just another resource that we're looking to use from an AI perspective to help consume that information on the protocol, break it down to discrete components, and then be able to map those side effects, so we're not having to do this very labor-intensive mapping by hand. And just because we're running a little bit short of time, I'm just going to talk really quickly about kind of a second phase of this. So what I just was focused on was our preemptive symptom management pathways. We also are starting to build out are symptom management pathways that help guide our nurse navigators, helping them manage the side effects that patients are actually experiencing. So this is primarily focused on telephone triage. So these are a set of pathways that basically provide standardized assessments and, again, standardized dynamic recommendations using a smart set in Epic. And what basically happens is when our nurse navigators are triaging symptom calls, they're creating specific encounter types in Epic, and we're building out a set of standardized smart forms that, as you're responding, which you'll see here, actually auto-generates portions of the note for the nurse. And then on the left-hand side, which is really important from a TriSoTech perspective, is we're actually building out in our practice advisory and we're using our practice advisory a little bit differently than the alerts we use for our preemptive symptom management. This is really more of a way for our nurses to be able to reference very important information about the patient in a very specific location. Because as you can imagine, and you can just see here, this is a user interface where we have already either collapsed or removed a pretty big portion of tabs that are typically there, but even then, there's a lot of information. So basically what we're using TriSoTech for in this instance is to aggregate data that otherwise a nurse would have to navigate out into another tab in order to find that data, or there are a lot of situations where there are things that the nurse needs to know that are not discretely documented in the EMR. For example, whether or not a patient has been on immunotherapy in the last 6 months. Actually, that, from a workflow perspective, is a very difficult piece of information for a nurse to locate, because if you think about it, you either have to look back through their medication lists, or if the organization has built out treatment protocols in Epic, they'll have to go back and look through the treatment history, find the dates, et cetera. So this is something where we can very easily, in TriSoTech, consume the med list, consume the treatment history, scan those dates, identify certain drugs, and then push back as a single field to whether or not the patient's received in the last 6 months, right into this OPA user interface, and display that to the user. And so this is something that, again, this is just an overview of how kind of technically we do that. There's some other work that we're looking at doing around some of the billing for the services that our nurse navigators provide, and there's certain criteria that would make a patient eligible for that. So we're also looking at actually being able to directly integrate with some of our payers' claims databases to be able to scan actual raw claims data to figure out, for example, if the patient's been on hospice, if they have certain ESRD diagnoses that would exclude them, et cetera. And this is just, again, another overview of kind of the auto-generation of the note. And so very much quickly in conclusion, again, we've already talked about a lot of this, but again, we really use TriSoTech for this BPMN and DMN modeling. We heavily leverage the CDS hook deployment, which is shown here. And then again, our kind of newer phase is that nurse education triage workflow, which will be leveraging a very similar model to what we do for our preemptive symptom management pathways. We talked a little bit about the AI piece. We talked a little bit about the intelligent triage routing and some of the standardization that we're working on there. And then just kind of these key takeaways, which we just talked through. And I will stop there and see if anybody has any questions, because we are out of time.